Our world is increasingly complex and interconnected. Humanity is challenged with understanding and adjusting to ever-changing social, economic, and environmental factors as a result of a growing population, increase in disasters, extreme climate, among many other variables. Our future relies on a whole systems approach towards sustainable and innovative solutions built on reliable insights, information, knowledge, understanding, and informed decision-making. Over the last several years, humanity has experienced extreme weather events, some of the worst hurricanes, droughts, wildfires, and man-made disasters in recorded history. This year alone, NOAA declared that 2023 set a new record for billion-dollar disasters, exceeding $23 billion in damages. Coast to coast, the U.S. has experienced extreme drought, excessive rainfall, flooding, and wildfires. Similarly, the global community has experienced significant increase in frequency and magnitude of these events that have cost trillions in recovery. The Maui wildfire that affected the United States from August 8th to 11th resulted in a record number of deaths exceeding 100, destroyed 2,719 structures, and caused $14 billion in damages. Canada experienced 6,595 wildfires, with 45.7 million acres burned in several provinces including Nova Scotia, Quebec, Ontario, and British Columbia. Wildfire disasters like this are occurring all over the world, including in Greece, Jalisco, Mexico, in the Castilla province of Spain, Chile, Turkey, and several other countries. The ability to effectively share, use, and reuse geospatial information and applications in support of disaster response and resilience is dependent upon having a spatial data infrastructure already in place when disasters strike. Humanity needs innovative solutions, modern spatial data infrastructures, place-based understanding, and generative Earth insights and intelligence to respond to an increasingly uncertain future. Public and private sectors, academia, nonprofit organizations, and communities are working together with the Open Geospatial Consortium to create and share trusted data, knowledge, and technologies to improve resilience. Our aspiration in this pilot is to bridge the divide between stakeholders and providers of data and services to reduce loss of life and property to improve preparedness and resilience in the face of an uncertain future. In this pilot, we demonstrate how advanced SDI architectures and interoperable standards help stakeholders and decision makers make new and beneficial perspectives into social, economic, and environmental issues related to climate and disasters. For this pilot, participants focused on research and engineering of advanced architectures, interoperable standards, and workflows that support registering of structured and unstructured data, data profiling, and spatial data enrichment to increase trust of data, models, and emerging GeoAI using W3C DCAT, ISO, and OGC standards. Collaborators engage transnational organizations and stakeholders throughout the community to understand requirements for geospatial framework datasets that address specific indicators and work broadly with local to global providers to mobilize high-value social, economic, environmental, and other data, services, and models to support the pilot. These trusted sources of data, models, and workflows were registered in the identified solutions and sourced to generate a wide range of products and services in the pilot. The team selected Terra.js, ArcGIS Hub, and Voyager Search, spatially enabled COTS, and open source platforms to establish an interoperable data mesh architecture that enables federation of local to global data, services, and workflows that can produce products and services. The first demonstration utilizes Terra.js. Terra.js offers registration, cataloging, mapping, analytics, and workflow capabilities in empowering stakeholders to search, view, and explore registries and catalogs of geographic tiles and services. The platform enables registration of content, URL-encoded parameters, map visualization, and workflows. Using indicators identified by stakeholders, collaborators developed a registry using Terra.js JSON coding requirements for DCAT and OGC data retrieval services. The graphic illustrates samples of the code, search in the registry, and mapping using OGC services that respond to fire and drought indicators. Mapping and analytics are showcased, addressing use cases related to communities at risk, open and participatory science, wildfire, drought, and health. Participants tested the ability to find and use SDI foundational data, topical and thematic data products to address public health threats related to changes in climate and natural hazards. Participants were asked to search for responsive content, map the resources, and build the story using environmental, drought, flood, and climate risk indicators from providers and health risk indicators from HSR developed during the pilot. Using Terry.js story feature, stakeholders utilize map services, workflows, and other content to understand the socioeconomic health, wildfire, drought vulnerabilities, potential climate mitigation, resulting from green infrastructure, and other insights and intelligence. Resilience coordinators and emergency responders require access to data that may include social, economic, and environmental variables, and specific documents and information to effectively plan for, respond to, and recover from disasters. The second demonstration utilizes ArcGIS Hub, which offers registration, cataloging, mapping, analytics, and workflow capabilities, empowering stakeholders to search, view, and explore registries and catalogs of geographic tiles and services. The collaborators worked to identify key resources identified by stakeholders through the ArcGIS Online Network, Esri Atlas, and many other open data sources, catalogs, and repositories. The team registered over 533 total resources through ArcGIS Online. The Hub registry supports the use of W3C DCAT standards to provide an open API endpoint for stakeholders to programmatically search and retrieve content. ArcGIS Hub supports various file formats for data and resources, allowing stakeholders to work with a wide range of content. The Hub also allows federation of open data groups within the ArcGIS ecosystem, and partners can provide access to group content that can be manually added. The collaborators investigated the potential to bulk register resources into the ecosystem, and the partner was able to demonstrate this capability in one of the collaborators' environments. Stakeholders highlighted the general need to address barriers to field-based data collection from participants. Participants in the pilot worked to demonstrate the ability to ingest data using geo-enabled mobile applications. Hikers, campers, forest rangers, and citizen scientists can help protect their favorite outdoor areas by collecting data to assess and mitigate fire threats. With billions of dollars spent collecting data, and with much more spent to share and catalog data, why is it so hard to answer simple questions such as how many houses were damaged? Has there been any oil spilled in my area? Are changes in vegetation indicating a change in our mapped ecosystem? Stakeholders need trusted discoverable data to be able to efficiently find and use data. Data derived from many sources is needed to be resilient and responsive during a disaster event. Additionally, efficient access to models that can quickly synthesize large amounts of data is needed to timely deliver results to decision makers. During a disaster, various types of authoritative data are crucial for effective disaster response, management, and recovery. These data types provide valuable insights that can help authorities, organizations, and individuals make informed decisions and coordinate their efforts. Using new technologies to save lives, that's where Disaster Pilot 2023, registration, search, and discovery of data comes in. Bringing together disparate data involves the process of integrating or consolidating data from various sources that might be in different formats, structures, or locations. When coordinating emergency response efforts during a natural disaster, geospatial data must be fit for use to create accurate evacuation routes, assess the extent of damage, or identify vulnerable populations. The data's quality and timeliness are crucial factors, as outdated or inaccurate information can hinder response efforts and potentially endanger lives. The cornerstone of fit for use and fit for purpose is data profiling. Data profiling is an integral component offering a comprehensive analysis of data assets. It involves assessing data quality, structure, and content within a dataset, model, workflow, or service, evaluating the authenticity, accuracy, and reliability. The collaborators utilize manual, algorithmic, and generative workflows to complete an initial assessment to determine fit for use and fit for purpose. The registry was engineered to support quality and validation checks utilizing ISO 19157 and ISO 9001 standards pre-ingestion. The registry employs out-of-the-box and customizable templates and workflow processes that apply business rules based on regulatory, organizational, industry, and other content representation standards, roles, data classification, security, sensitivity, quality, and various other rules. Collaborators in the pilot also developed a lexicon and integrated the use of reference libraries into the registry engine to support consistent and efficient categorization and classification. The participants' registry employs a flexible search architecture that leverages open source technologies in the organic data science ecosystem enabling collaborators and stakeholders to narrow down their search results and discover insights and intelligence by applying the following features. This hub features an intuitive search box enabling users to conduct queries based on locations and specific facets. It offers a suite of filters to refine these searches further, ensuring greater precision in the results. Additionally, the system retains a history of past searches, providing users with convenient access to their previous queries for future referencing. The collaborators in the pilot validated use of current standards, tested data mesh federated architectures, new standards, developed integrated profiling workflow that leverages GeoAI deep learning for detection as a service. Voyager provides an integrated processing engine that accelerates the transformation of data to insights, knowledge, and intelligence. This pilot demonstrated these capabilities in the detection of oil spills, landslides, solar panels, buildings damage assessments, mangrove, solar, wind turbine detection, and storm tracking, as well as imagery related to flooding. On behalf of the GeoPathways, we would like to thank OGC, our federal advisors, and especially the participating partners who contributed to our research, development, and ultimate success in this project. And on behalf of our team, we offer a special thanks and gratitude to John Swanson, who served as our project manager and coordinator on this activity.